Okay, I believe we are live. What we're going to do is do a check, make sure we're live everywhere we need to be. And I'm going to just do that whilst the rest of you do that. And then we'll have these introductions and we'll have this conversation, which should be great.
Yes.
Let's
And a big description, a long one, Wasim.
All
Very
right.
long.
So, yeah, we're all just going to check. Should be live there. Yeah, we're live on LinkedIn, which is great. So I can see.
Hello, good evening, good afternoon, good morning, wherever you are in this world. I see people are watching live right now. We have Hashim.
It's not live on my Instagram yet. Yeah, so we need to.
Yes, I'm getting the comments already. So, guys, please bear with us. We are still setting up a few technical things to be live on all the channels. Meanwhile, get your questions ready because we have good people in the house who
All
can
right.
answer everything.
So this is what we'll do. We'll start going into this. So welcome everybody. My name is Wasim. I'm the CEO of Metavisionaries, and today we are joined by a stellar team. What we have is Dr. Jim Green, who was the former chief scientist of NASA, who is currently the chief scientist of the Metavisionaries. We have Hashim here, who is one of the most prolific science communicators I've come across, and it's such a pleasure to have you, and of course Sabrina, who's joining us with the Metavisionaries team, and will tell you a bit about everybody. So, Jim, if you want to quickly introduce yourself, and then we'll go to Hashim and Sabrina. We'll take it from there.
All right. Well, I'm Jim Green. I just recently retired from NASA after 42 years. And yes, 42 is the answer. And by the way, I had a fabulous career. I did work on scientific projects and more than 24 NASA missions. I had the pleasure of running NASA's planetary program for 12 years. Everything from flyby of Pluto with New Horizons to the landing of Curiosity and Perseverance, along with Ingenuity helicopter on Mars. So just a wonderful experience, and I'm just delighted to be here to talk about anything you want to know.
Great.
Wonderful, Hashim. Welcome.
Well, thank you so much. I'm very glad to be part of this amazing crew today. My name is Hashim, and I'm a science communicator. I have been communicating science since 2009 on social media, mostly right now video content. And I have over 20 billion views on social media from different channels.
That's great.
And currently working on a sci-fi film called Orbital, which is a feature film. And also will publish my first sci-fi novel in May, which is called Simulation: The Great Escape, about the simulation hypothesis.
Fantastic,
So,
Sabrina.
that's all
Welcome,
about
because
me.
you brought us all together. So say hello.
Hi. Yes. Sorry. I'm Sabrina Terence. The people who follow me know who I am. I'm a DJ artist, and I am the Future Emerge Community Officer for Metavisionaries. Very excited to bring you all together, especially Hashim and James. I'm so excited for all the questions out there because I know that all the people who follow us have always the same one important questions we're going to start with. But I haven't retired yet. So I'm still working, and hopefully another couple of years with you guys.
Excellent.
Right. So we'll start this session off. The whole role of this conversation is to discuss space, the metaverse, and its applications. So welcome everybody for this session. We're gonna answer all your questions as well when we have them. So I can see there's loads and loads of comments already. So we'll come to that. Wow, more than 100. Okay. So let's start with this. Hashem, I'd love for you to start telling us quickly about yourself and how you started, and your interest in space, and the work you've been doing, and why you've been doing it. And then from there, we'll love to ask you to join Jim and Sabrina and ask some of the questions you have, and then we'll go topic by topic from there.
Yeah, well, for me, I started science communication, as I said, in 2009. There was a time in my childhood where I used to publish science facts in children's magazines, printed children's magazines, and it was really cool to share facts with the others. And then in 2000, at the end of 2008, the beginning of 2009, I discovered Facebook for the first time. Yeah, and I thought it was a fertile ground to reach more people, and I decided to use it to publish content. In 2015, Facebook switched to video content, and I decided to focus on video content. And I do this honestly because, first of all, there is a lot of misinformation out there, and it's a good way to tackle misinformation. Second, I feel like I have what it takes to deliver information to the general public in the simplest way possible. And I blend my degree in molecular biotechnology, my science degree, with my ability to create graphics and combine them together to make science interesting and engaging.
Great.
Wonderful.
Can I ask the first question, because we are already live for almost 7 minutes and people are so curious out there. So the first question we all get, I'm sure Hashim, you know it. I'm sure James, you know it. Wasim, you know it. I read all the comments right now in my live stream, and people are asking, is there something out there as in aliens?
Well, NASA has a program for which we've been searching for life beyond Earth, not only within the solar system, but within our local neighborhood by looking at planets within our galaxy. This is an element of extreme interest, not only to the public, but certainly to the space agencies. And I think they've been doing a great job. So far, the answer is that NASA would say is that we haven't confirmed a discovery of life beyond Earth. However, we're making enormous progress in that area. I know everyone wants the answer to be yes or no, okay? But in reality, how we have to do it is like walking upstairs. We have to create a series of scientific discoveries that build on each other for us to be able to confirm life on another planet, on an exoplanet, for example. We have the framework in place. We have some of the most exciting instruments, with the launch of James Webb Space Telescope, making wonderful observations that we've really wanted to do. And then, of course, with Perseverance and Curiosity on Mars, we're looking now at, with Perseverance, coring rock and bringing that rock record back. Well, why is the rock record important? Well, here on Earth, there are more than 5,700 minerals that we've identified, and 300 of them are made with dead life. So the rock record is critical for us to understand of life in the past. We know there's no life on the surface of Mars now, but perhaps in the past.
So the answer is not sure.
I believe NASA is not sure. Well,
the answer
don't have
is
evidence yet, I guess.
But
NASA.
We as scientists have a feeling. We are human too, in the sense that we perceive, or we use the knowledge that we have to make some have thoughts of our own about that. And so many of us, and you would include me in that bucket, would say, I think it's inconceivable that our universe would not have life. I think life is out there, and it'll come in all the forms that we have here on Earth, in the sense of simple life, like microbial life, to even complex life, like humans are. Complex life meaning the body is made up of all kinds of different cells that support different functions, and as simple life evolves into the more complex, I think those kind of things must be happening out there. Although we don't have proof that that's the case at the moment.
Right. Maybe the proof will come when NASA brings some rocks from Mars, which is
that's right.
In one of the future missions, I believe, right?
Correct. Yeah. Correct. That'll be
Tell us a little bit
step.
about that, please. Yeah.
Yeah. So Perseverance.
When is the rock going to come from Mars?
So we're coring the rock right now. We have more than 12 samples. We've already cored the rock. We have a cylindrical drill that then, once we have selected a site, that we can drill into the rock. And of course, the rock record's been built up over time. So the further we go into the rock, the further back in time we go. And we know several things about Mars. And one of the key things about Mars is that its early Mars had water on it. And I mean, it was a blue planet, just like the Earth was. 2/3 of the northern hemisphere was underwater, and in some cases more than 1.5 kilometers deep. So that's great for the potential for life, because we believe water here on Earth is essential for life. We know that for a fact. And if water is on another planet, we believe that it provides an environment
but what if
where life could exist.
My question is, maybe an alien life would not have to rely on water for its existence. It could be some other chemical that we don't know. It could be silicon-based, right? It could be robotic. It could be... so it's very hard to define life on the basis of what we know here on Earth.
So one of the first things I did as head of planetary was to ask my astrobiologist, give me a definition of life. I want to know what we should be looking for. Can we get a definition that then builds instruments that allow us to go to, the moon or Mars or even Venus, and use those instruments to find indications of life? And so the astrobiologist spent a little time, and we wanted to make it, a solid definition that doesn't require that it be human like us. And so it has to be a general definition. And they came back and they said, here's the definition of life. Life has 3 attributes. 1, it metabolizes. That means with food, you need a solvent to then extract the energy, and the solvent then it takes away the waste. All right. For humans, that turns out to be water. But it could be liquid methane or other types of liquid in other environments. It doesn't have to be water. The second definition is that it reproduces. And the third is that it evolves. And if we find those 3 attributes...
That's the most important trait.
Those are the 3 most important traits. If we find those 3 attributes on anything, we're going to call it life.
I recently asked a question to my audience, which is, if we found microbes on Mars, should we leave it to the microbes? Because long time ago, there were microbes on Earth from which all life evolved, and we have all of this wonderful biodiversity. So if we interfere on whatever life that exists on Mars, we could be preventing the next stage of evolution. So the question is, should we leave it to the Martians? I mean, even if they are microbes, we can call them Martians. Or should we just, continue human activity?
All right. So
what do you think?
So from my perspective, if there's microbes on Mars, we don't believe they're on the surface. They're underneath the surface. They're in aquifers. Now, we believe that that's the best place to find life right now, because we find an enormous amount of biomass of life here on Earth underneath our feet. In fact, there's more life in terms of the biomass total below our feet than the biomass on the surface of the earth, and that includes all the biomass in the ocean. Life has got a hold of this planet. If we look at Mars today, what's happening? Mars is in a different point of its evolution. It's lost most of its atmosphere. A significant amount of the water is gone, although Mars holds an enormous amount of frozen water in the crust, and lower in the crust is the liquid water, and that's where the microbes could be. But in answering your question, should we leave Mars alone? It may be, in one particular view, that life is on the way out, that Mars is evolving such that the microbes are doomed to die. And by having humans there, that actually might save the life on Mars. That's a history or an alternate way of looking at it.
That's a very interesting way of looking at it.
We should not forget. Yeah. So to me,
Sabrina, you have a question?
If we find life on Mars, it's below the surface, and I believe we can live, we can cohabitate, because we're going to live on the surface and the microbes will live below the surface. I think we can find a way to do it.
Okay, fair enough. Yeah. Sabrina.
Yes, I have always questions. I see all the comments, and I have a lot of questions anyway. Okay. But let's come to the question, because since you're talking about life on Mars and everything, Hashem, you have been posting something about aliens maybe using black holes as quantum computers, physics say. Where's the evidence, science-wise?
It's all mathematical equations. Okay, as you know, most of these rely on theoretical physics. Okay, and they use mathematical models. And, you know, the recent conclusion was that black holes could be part of a massive quantum computer used by aliens. And it's a very interesting hypothesis, but it remains a hypothesis right now. What do you think about that, Jim?
I'm not crazy about that idea. Sorry.
I mean, there is this idea that we could be living inside a simulation. Who knows? Maybe part of the simulation is the fact that black holes are part of the quantum computer that is running the simulation. I mean, there is also another hypothesis that says that the universe exists inside a black hole.
Well, you know,
so if the universe exists inside a black hole,
what we know about our universe is that we indeed can see a certain distance, you know, based on what's happened over time in our theories of in cosmology, that the Big Bang started, 13.7 or so billion years ago. And we think we can, you know, with Webb, look back to nearly the beginning. There's other ideas on how to look even further back using radio waves into the dark ages, we call them, where the universe starts out mostly, with the very basic part of elements like hydrogen and the protons and electron environment. So what could happen, of course, is that a distance even further from Mars is another universe that has started. We have no way of knowing that. You know, so parallel universes may indeed be occurring. All we can do is see the one that we have and think about, because we have the ability to think creatively and with the knowledge that we have acquired over time, what also might be out there.
But there is a way to see beyond that, which is Einstein's cross, which works like a giant mirror reflecting off space from the back, right?
Yes. So indeed, gravity is one of the fabulous forces of the universe that's, that allows stars to occur. And inside stars make material. You know, Carl Sagan said so eloquently, we're all made of star stuff, begins in that center. And of course, gravity also warps space around it. And so light actually follows a route for which it will bend in that space. And so Einstein got that right, which was pretty spectacular discovery. So the concept of, well, have we really uncovered all the physics that we need to really understand the universe? And we may not. We may have more surprises ahead of us. I think we're really just awakening to our ability to describe more and more of the universe, and we have still a lot to learn.
Wow. Sorry, I just hear the word awakening from you, James. This is so exciting. Awakening is actually a word which a lot of people on our planet are using right now, but that is more like a spiritual thing as well. So I'm not going to go into that because I really want to keep it more scientific here. But Hashem, actually, I have a question about space travel, and maybe you and Jim, you can answer that. People asking the question, is it really possible to do space travel in the next 10 years, like SpaceX or Blue Origin, like Elon Musk is doing an advertising, but everybody says it's not possible because it's expensive. But
You mean
the other
space
day
tourism, I think. You mean
yeah,
space
but
tourism.
the other day, James, you told me that even when the first airplane was flying from A to B over the planet, nobody was believing this is possible. And then 30 years later, everybody was using economy flights, right? So how about space travel?
Well, from my perspective, yeah. I think the aviation industry is just now seeing the possibilities of how getting into low Earth orbit may be of an enormous benefit in terms of traveling on this globe. Think about it.
But it's very expensive. $250,000 for a single trip.
Okay. Do you have any idea what it was when we were doing it in the 60s? It's gotten cheaper.
What was it?
What
was it in the 60s?
I'd have to look it up, but it was probably 10 times more than what it is today. So space travel is getting more and more affordable, but the bottom line is the ability for humans to be able to get into low Earth orbit and travel around the Earth. Once you're in low Earth orbit, you circle the Earth in 90 minutes. I can imagine a time when people will get into a vehicle, go into low Earth orbit, and in 45 minutes begin the landing process and go from Washington, D.C. to Japan in 45 minutes. Okay. Do we want to do that? And the answer is, yeah, I think so. I think there will be a market for that.
Okay.
Definitely a huge market, but it will be limited to certain individuals. Still, it's a great start.
Okay. So in the 30s, this is what we were just talking about, Sabrina and I, in the 30s. Imagine yourself in the 30s. Okay. Where you're still walking down the street and 10% of the population are using horses. And investors backing Charles Lindbergh, where he then took their money and made, the Spirit of St. Louis, and then flew from the United States to France, okay, in something like 32 hours. And first transatlantic flight, and the people at that time were going, this is fantastic. I can see a future. Well, we'll do more of that. But others in that time were saying, why would you ever want to go to France in 32 hours? I can get on a boat and be there in 7 days. And now, flying is ubiquitous. It did start out that only the rich could afford it, and as companies got going and new techniques were found, the ability to build these safe structures, and safe as flight today is one of the safest ways to travel. Why not? Why not use low Earth orbit? What's stopping us? Yeah. Is it money? Is it imagination?
It's true.
We have both of those.
No, it shouldn't stop us. Definitely, we should definitely proceed with this endeavor. I think it's a
Absolutely.
great idea. Yeah. Yeah. All right. So I want to ask a question. What do you think about the UFOs that everybody was talking about? They are still crazy about them. Are
right now.
they aliens? Hmm.
Well, UFOs are unidentified. We don't know what they are. We need more information. NASA now has put together an august group of scientists to work with the U.S. government to look over all the observations that have been made and try to really understand a little bit more about the constraints, really understand a little bit more about what additional information is needed, and perhaps set up the capability to gather that information. So, over time, we might be able to learn much more about those, but we do need more data to be able to say definitively, those are, alien craft.
Imagine, and I'm just talking some crazy nonsense right now, that there is a big alien spaceship out there outside our solar system, which we have been thinking all this time that it was Planet 9, because there is this hypothesis that Planet 9 is out there, mathematically found, and they're sending these alien probes to see if we are friendly, and we just keep shooting them down, and they say, you know what? These people are not friendly. Let's just leave. And we missed our first chance of first contact. That would be a missed opportunity.
They will definitely call me friendly and beam me up there, Scotty. They they will have a tea time with me
Okay.
for sure.
You will be the
But
chosen one then.
yeah, yeah, yeah. No, the other thing is, whatever is out there, are we ready for it yet? That's the other question. But I would like to change a little bit the topic from this alien, because we are also having the Metavisionaries right now here. And it's a good opportunity, since we were talking about traveling to space and all of this. Is it affordable? Can we do this in the future or not yet? But actually, maybe Wasim, you want to say something about it because you are the CEO. You can actually explain what we are planning in the next couple of months, which is really cool with the Meta Visionaries.
So, first of all, I knew it was going to be bombarded with alien questions, and I thought, you know what, let that just happen. And I know we could speak for 1 hour on the whole aliens question. That's great. First of all, welcome everybody for joining this great live, and we've got some amazing people on here to talk about aliens, but also I'm hoping that we can shed light on what we're doing and why space is essential into everything we do over the coming years, as well as talk a bit about the Metavisionaries and in terms of the metaverse. So we came together just over a year ago, myself and Jim and our co-founders and partners from Space Applications. And the goal is to provide accessible, affordable access to the space sector, whilst also delivering on skills that are going to be required over the next decade to really excel and navigate this rate of change we're experiencing. So what does that mean? Well, what we do is we build physical space innovation labs, which are going to be connected to the International Space Station through our partners, Space Applications. And what that means is we can send payloads and science to space. And before we go into the metaverse part, I'm going to show you what that means. So currently, so there you go. See that? Yeah, we're gonna come on that. These space innovation labs allow anybody or any country without a space agency to have the ability to connect to space. And we are now about to send the next experiment with Professor Joseph Borg from Malta, who is part of this network. The goal is to create 25 space innovation labs. And our lab in Malta is about to send a cube, which I will show, to space. And this cube in space will carry tissue cells from patients in Saudi Arabia, as well as Malta, and hopefully soon maybe Oxford as well. And these cells are for patients suffering from diabetes. And we are going to be
Oh,
looking
wow.
at these. Yeah, and we're going to tell you why specifically we're looking at patients with diabetes suffering from foot ulcers. But first of all, what do I mean by space? What the hell am I
Yeah.
talking about space from cubes? So let me show you.
Yeah, let's go.
So
I was
this
actually trying that. Oh, okay.
Right. So this is the previous experiment we sent. So another one is going to be going to space where we're going to be showing. So what I'll do is pause it here. This cube here will contain live samples like it previously did. As I said, 6 will also be coming from Saudi Arabia this time. And we're going to be using this environment of microgravity to understand how things differ in that environment. Now, why in this environment? In fact, we got asked this a load of times. So, Jim, I want you to explain, why are we sending experiments to space? Why are we trying to figure out what will happen to the microbiomes of people with diabetes in a space station?
Well, space is, as we've discovered with our astronauts, a real stressor on the body. All kinds of different things happen. Some processes work fast, like the body starts leaching calcium out of the bone and it becomes more fragile because the body doesn't need the structure that we have here on Earth. There's no, little or no gravity, as we call it in space station, microgravity. And so there's also things that move slowly, where gravity here on Earth is exacerbating arthritis and causing inflammation, and the bones are rubbing together. In space, you don't have that, but you have still the conditions of a person that then is moving into an arthritic phase. So space is a stressor to the body. The body responds. And we now know that we can take advantage of those things that move rapidly to do a rapid turnaround and understanding how the body responds and be able to help it in its cure, or be able to prevent it from destroying itself, as sometimes that happens. The body overreacts, like an immune system problem, and take advantage of those things that move very slowly. So space is providing us a unique opportunity to be able to study the body in ways that we've never done before. And we're already seeing that there's going to be a number of major medical breakthroughs because we can do these things in a microgravity environment, and we can only do that in space.
Wow.
Absolutely. And this experiment, we're going to have some fantastic news to announce in terms of the people who are going to be there. And this is just an example of what we can do and how we can bring it closer to everybody on the planet. A lot of people say, well, there's billionaires flying to space and there's rockets going, but what has that got to do with me? Well, there are a lot of people who suffer from diabetes. And this is a real example how we can utilize that environment and what we can do with that. We'll continue to show other use cases, but this is one example. And so not only building these physical space innovation labs, they are all going to have our metaversity and metaverse environment that we've created. So you can be born in Rwanda, you can be born anywhere in the world, and you can have access to this technology. How you say? Well, let me take you to the next stage. So
communicating with the orbiters, to
And Wasim, you
communicating
don't need
with
the
ingenuity,
goggles, right?
communicating directly back to Earth.
no, you can come
And
on
so
through your
each and
Oculus
every one of those plays
or
an
your
important
laptop,
role.
or even
Now
your
we
phone.
can show and visualize on the rover itself what those systems are like.
Now you might know this individual. He might actually be
That's
on
Jim.
this screen. Yes, it is. So I was going to let you guys ask, but there you go. Sabrina answered it first. So that's
Sorry.
Jim in the metaverse. No, it's fine.
That's my avatar.
So Jim, just explain what you're doing here, and how that felt for you, because Jim helped us design this metaverse application.
Well, we're in a meta ship. This ship is a beautiful glass dome with lecture hall capability, where other avatars from people all over the world can walk in, and then we can talk about some of the things that are going on in space. Now, here is a full-scale model in virtual reality of Perseverance. The thing about it is it's to scale to me. Here I am, 6'3.5", and I can walk up to it, and even the top of the mask is taller than I am. This is a 1-ton rover. It's got all kinds of capability associated with it. It's measuring weather. It's, temperature, pressure, wind velocity. It's taking in the air, which is carbon dioxide, and making oxygen out of it that then demonstrates how we would be able to live and breathe on the surface of Mars using, what the movie The Martian called the oxygenator. Well, we've got an experiment where we know how to do that. So we take that knowledge and be able to apply the physics for these kind of things in the future for which are necessary to survive. And this is the rover that's coring rock. This is the rover that's sitting in an ancient river valley where the delta has deposited material from way upriver that's come down, dropped in this area, and is built up to an enormous height, about 65 meters of material that has flowed down this river and is deposited in this crater called Jezero. And therefore, we can core that rock and we can bring it back, and we're going to be looking for the potential opportunities to find life in the rock record. And we do this in the metaverse by introducing how we really pull this off.
Hashem, you've been a science communicator. Sabrina, Hashem, you've been a science communicator for so long. What do you feel about metaverse application, and from what you've seen in terms of education, and how you feel it could really help bring people closer to STEM and STEAM and science, but also not just learn, but be able to apply what we're doing there?
I think it has so many fantastic opportunities, especially for explaining complex information. I have seen some apps on the metaverse where you can navigate inside the living cell. I remember when we were at the university and we were studying how the cell works, and we were only relying on drawings, it would take much longer to understand. But to be inside the cell, to move around, to see all these organelles, to see all these compartments inside the cell, to see the proteins, the nucleic acid moving around, it felt like you are really inside the human body, and the learning becomes more enjoyable and more fun, and you don't have to take much longer to explain complex concepts. So I'm really very excited about it.
Now, we've had Hilda join us, one of our partners who was here throughout this very demanding week. And we just worked nonstop and did nothing, no partying, no nothing, Hilda, since you've left. Hilda, I'd love for you to introduce yourself and tell the world why such an exciting time for space and the metaverse and education. And I know Hilda's been partying a lot, so we'd like her to do some work on this call.
Partying a lot in the metaverse or real world?
Does it matter? Does it matter?
Both are great.
Yeah,
Welcome.
And it's so good to see you all, and so good to be with you from quite a distance, but close nevertheless, thanks to all of the digital means. And I think that's what you were touching on with the metaverse as well. And so when I joined and when I got in contact with Wasim and Jim, soon after we had one event in the metaverse, which I thought was very interesting and very immersive. And you were saying, Hashem, how interactive it becomes and interesting to learn. But I think also the social aspects, the fact that you can collaborate and sit next to people, I mean, in a way like we are now, but it's very different at the same time, because you have this bubble in the metaverse where you can talk to the people that are sitting next to you, and you can chat and gossip even. So I thought that was really fantastic. And so, as matter of introduction, so Wasim was just showing these cubes, and that's what we do. We bring those to space for anybody who has ideas of wanting to do things in space. And so connecting these with these space innovation labs that Wasim talked about, and with the metaverse, we think is a fantastic synergetic way of learning for anybody around the world that maybe cannot easily access an agency, but now has immediate access to Jim talking about space, or anybody talking about space, to those cubes that actually are physically in space, and you can see them, and you can see them in the metaverse, or you can see them. Oh yeah, I just saw that, Sabrina. It's one of your artworks. I know.
Yes. Oh my God. Yeah. My
Yeah.
first exhibition in space, because something different, right?
I want to bring something here. There's a number of questions I'm going to come to. We've talked about science, and I'm sure there'll be more science. And people say, okay, but I'm a creative, I'm an artist, or I'm a musician. What has this got to do with me? First of all, Sabrina, you were inspirational in the very fact that you're a creative, you love your music, you love your art. And what I'm going to play now is what Sabrina did. And Sabrina, I want you to tell everybody why you did what you did, what is what you did, and why everybody can do it.
Yeah. Wow. Yeah. So
Now this painting is worth more, huh? Because it traveled to space.
actually, that painting is in a museum in my hometown in Germany. Yes. So I had the opportunity to sell it, but I didn't want to sell it, because for me, the whole idea was I'm 16 years a DJ. I traveled around the world. I've met so many people, cultures, and I have seen so much on Earth that I was thinking, when I started painting in 2015, 16, my first exhibition, I didn't want to have it in an art gallery on Earth. So I was always fascinated by space and the universe. Since I'm a child, I had a telescope in the garden looking out for Saturn. I said, let me send it up to space. It cannot be that difficult. So I contacted this company. They helped me in a helium balloon. We set it up. The original painting was bigger, but unfortunately too heavy. So they told me in 24 hours, paint again. It's too big or we cut it. So we cut it actually smaller. And at that day, I had no idea it goes up and it comes back down to Earth, but it actually landed back on Earth thanks to the GPS tracker, the tree climber in Germany who was going up 20-meter high. That painting was actually 200,000 feet high, 65 kilometer. And if my painting can go up there, I'm sure a lot of other things can go up to us, the Metaverse, the Metavisionaries. I'm sure in the next 10 years, everything is possible. Yes. Why I send it up? To just be unique and do something different, and of course to spread love and light.
Well, I think these things are so important.
It's a great idea.
We really need to bring more awareness to why utilize space. Now, I want to touch upon something. I can see someone in the comments, and this is something, Jim, you get all the time. And Hilda, I'd like you to touch on this, and Hashem, you as well, because you communicate this. Why do we want to go on space? There's so much on the Earth that needs solving. There's so many problems here. We've had these earthquakes in Turkey. Why are we talking about space? Why do we keep mentioning it? And this is a question that everybody asks. So Jim,
well, that's one of the reasons you just meant. Yeah.
Go on, Hashem. Yeah, no, go for it.
Okay, so I'd say you just mentioned some of the reasons. There's a lot of disasters, and they keep happening, whether they are natural disasters or human-caused disasters like climate change. We don't want to give up on planet Earth, and we're not giving up. There are people who are working on solutions for that, but it doesn't hurt to also work on additional solutions like space travel, going beyond Earth, looking for places where we could expand human civilization. So it's a contingency plan, and it should be there.
So that's the
Plus, space is
contingency
fun.
plan.
It's very cool. It's very exciting.
No, great. That's the contingency plan. But Jim, why should we care about space for Earth?
To me, it's being in the space business, I've seen an enormous number of exciting scientific discoveries in the solar system that relate directly to the Earth. For instance, the concept of climate change, where does that come from? It actually comes from scientists that are looking at Venus. When the data coming back from Venus indicated that the surface was hot enough to melt lead. How did that happen? Well, after studying the environment and creating computer codes and analyzing it, they determined it's a runaway greenhouse effect. Those scientists, those NASA scientists took those codes, brought them from Venus to Earth, got them up and running, had wonderful global circulation models, and then began to tweak them by adding CO2, by having the addition of CO2 that humans are bringing with them in terms of the way we live in this environment. And then the temperature starts to increase. The key was that now we can predict what will happen in the future. Also, how do we monitor the climate and how it's changing? Well, we want one number. We want to know the average temperature of the Earth. Well, how do you get the average temperature of the Earth? You put a grid on the Earth, and everywhere on that grid, you put a thermometer. It's over the poles, over the water, over the land, and you make a temperature measurement every 30 minutes. And then you take all that data after 365 days and add it all together, and you get one number as an average, and that's the temperature of the Earth. The problem is we can't do that from the ground, but we can do it from space.
Wow.
So not only do we have an understanding that what's happening in this globe over time as climate is changing, but we know how to monitor it too. In addition to that, how did we recognize we had a problem with the ozone? Once again, once we determined that a hole was being created, ozone was being destroyed, and as the ozone circulates at 20 kilometers above us, the lack of ozone first shows up in the polar regions because the total amount of ozone is going down. Even though you destroy it above certain places, that all gets filled in and it's taken from higher latitudes, and that comes in and the hole shows up. Well, where did we figure out how to fix that? Once again, that turned out to be Venus. Venus told us that the scientists were seeing how ozone was being destroyed at Venus because of the chlorine. And now we knew that CFCs, chlorofluorocarbons, the chlorine in that is what is destroying the ozone. So comparative planetology is really critical. What's happening at Mars right now? Mars does not have a magnetic field, doesn't have a magnetosphere that's holding back the solar wind in many ways, and the atmosphere is being stripped away by the solar wind. Well, what's happening to our own magnetic field? Well, we know the measurements tell us that the pole is moving and the field is getting lower. Are we about ready to see a flip of the field? And during that flip, we will have little or no magnetic field. What will happen to the Earth? We can tell you exactly what will happen to the Earth because we know by making measurements around Mars what the interactions will be. We're studying the physics of that situation at another planet, and we'll know what will happen here. So comparative planetology is critical. And that's just a few examples.
And
So
Hilda,
there's another thing that I'd like to add to that. I think it's great. We understand more about Earth by looking into space. Also, there's a lot of technologies that we are using today that are available to the general public, they started when scientists at NASA conducted research trying to send probes and rovers, and the cell phone, for example, which is now, I believe, is more powerful than the computer that put humans on the moon.
True.
Right. So, it helps us develop technologies that are more advanced, and these technologies become mainstream eventually.
Now, well, I know if you wanted to go to a restaurant, you'd plug in the coordinates, off you go. Well, where do you think you get that information? Well, you get it from the GPS satellites that are orbiting, allowing you to be able to navigate. We also use that with ships. We determine what the best lanes are, the areas where the oceans are such that we can navigate and save fuel. There's just an enormous number of things that are happening. Satellites can fly over countries and see the amount of land that's under cultivation, okay? And from that can predict whether the end of the growing season, that country will import food or have a surplus to export it. We will know right away at the beginning of the growing season. And that can only be done from space at the moment. So these are just a handful of the benefits.
And Hilda, I remember you and me had many conversations about, how do we get people to understand this and justify why this is essential and why this is important. So let's talk about some of that with your work, all this time you've spent. Again, let's answer that why question, because a lot of people are asking it.
Yeah. Well, I think both Hashem and Jim were touching on very important elements. I think you started with the earthquake. There's also quite some early warning system that basically use remote sensing, Earth observation, whether that's for earthquakes or for tsunamis or forest fires. Of course, and maybe we touch on that as well. If you then add a layer of artificial intelligence on top of that, of course, I mean, all these systems can learn so much more and predict even better. But Jim was just touching on crops. And if we think back of this environment of microgravity, that's also very interesting. Like, this environment can really teach us things that we can not learn on Earth, because it's a completely different environment where you don't need to deal with this gravity. So you can study, for example, crops and how they deal better with stressors, because you take out this gravity factor. You can study materials, you can study health of our human body and cells and so on in this environment in a way that is simply not possible on Earth. And if I may just come back on the art that Sabrina was touching on, because I do think it all relates, and I really see this as not one system of Earth and one system of space, but it's one integrated system where we should not think like space is niche and is only for scientific or no. I love to think of it as really one system where it's all humankind's assets that we can all reach, that we can all access, and where we can bring our culture, where we can bring our art, and where we can use all the different aspects of the space environment for the benefit of humankind here on Earth.
I want to bring up one more quick point, and then we should go back to the questions, and that is, we've discovered over the last couple decades, during the space era, that our planet is orbiting the sun in a horrible place. Why? Because we have a whole series of near-Earth objects. These near-Earth objects are being thrown out of the asteroid belt and end up crossing our orbit. The dinosaurs, which we believe 65 million years ago, and 85% of the other life that was destroyed during an impact of a near-Earth object on the Earth, can that happen again? And the bottom line is, yeah, we have many objects that could actually wipe out all life on Earth, and so we're finding them. We're cataloging them. We're watching their motion. We're predicting where they're going to be. We're ensuring that the Earth is not in any danger in the immediate future. We're making assessments, and then we're beginning a program to protect the Earth. And in fact, one of the last things I did as head of planetary science at NASA was to work with Congress and the administration to get the money necessary to do our first planetary defense mission. And it was called DART. And this mission went out, hit an asteroid, and moved it. And a big one, something that would destroy a significant city like Washington, D.C., if it struck at the heart of that city. And so consequently, that knowledge is so important. We have to be able to preserve life on Earth, and it's not just all about climate change. There are other hazards, and these are existential threats too.
Great point. Yeah.
Absolutely. So here's a question. In terms of living on Mars, realistically, what kind of timescale do we see that happening in?
Well,
and who is going to make it first, NASA or SpaceX?
Well, that's a good question. I believe firmly it'll be NASA. The government and companies like SpaceX form a great partnership. So although I think the government will lead that whole enterprise, it doesn't mean that it will be exclusive. I think other companies will be involved in other activities, and it needs to be coordinated. NASA's plans are to learn to live and work on a planetary surface first, and that surface is the moon. And in fact, we've launched a series of missions that really have studied the moon significantly and are ready for the next phase of humans landing on the moon, particularly in the South Pole, where there are vast resources that we are uncovered with our robotic missions. I think Artemis 1 now, which was tremendously successful, showed us that we have a rocket with the capability to get humans to the moon, along with an enormous amount of cargo. That's the same rocket system that can take us to Mars. Artemis 2 will have a crew, although they won't land. They'll orbit the moon and return. And then Artemis 3, within 2 or 3 years later, within a handful of years from now, we'll take astronauts to the surface of the moon. That's where we'll learn to live and work on a planetary surface and take that knowledge as we're developing capabilities at Mars. And oh, by the way, what are we doing at Mars right now? Well, we're laying the groundwork for humans to go to Mars because we're making the observations necessary to understand the risks, the hazards, what's there, what's the resources that we're going to be able to utilize when humans show up. And so I think we're talking about the late 2030s into the 2040s. I hope to be alive at that time. I'd love to be alive when we land humans on the surface of Mars. And I will do everything I personally can to help support that approach.
Okay, so we're approaching the hour mark. So what we're going to do is tie this up. It's been a fantastic discussion. I brought Camilo on, who's working with the team. Camilo, one of the things we were asked, why space? And obviously we're doing a number of events this year, from a team project to the space medicine course. Why don't you tell everybody what we have planned over the coming months? And then I'd love for all the speakers to have some last words, and we will say bon voyage to everybody.
Thank you, Wasim, for inviting me. It's been a fantastic conversation. I've been following from the backstage the whole time. So, well, for all the audience watching us, you have to keep an eye on our social media channels, because we will be posting a lot about all our current projects, not only on space education and, of course, our support using the metaverse, like augmented reality, virtual reality for space technology innovation, and, of course, for human space exploration. But because we have like our partnership with International Space University, with the team project in Brazil during the Space Studies program. We also have our big event in KAUST in Jeddah in Saudi Arabia, which will be talking about how the metaverse and space can be used for creating new ways to do healthcare, just to how we create new treatments using space. And also, our one of our last big events is going to be in Oxford in the United Kingdom in November with our executive space course, also with ISU, the International Space University, with medicines in space, how we do pharmaceutical research in space and how we can integrate the metaverse into that. So stay tuned, everyone.
Perfect. Thank you so much. So for all of you watching, I hope you join. Do reach out for some of the things we're going to be doing. In fact, we're going to be sending a cube, as we said, to space in just a couple of weeks. And in this cube, we hope to have some fantastic messages from Hashem, who will be streaming, hopefully from the space station, messages from Sabrina, and some of our other fantastic guests. So if you're interested about participating, please reach out to us on our handles. But with that, I want to, before I go and let the guests say one more final point, I just want to mention and just give you an experience from one of the other gentlemen who's been with us for a while, who came from a completely different background. So I'm just going to add him on. So Osman, welcome. I'd love for you to quickly, in 10 to 15 seconds, tell people you joined the space community. How did you find it? Why did you enjoy it? And why should people follow? You need to unmute yourself first.
You are muted.
He hasn't connected his mic yet. So Osman, I'll come back to you. But Hashem, you've been doing this for such a while now. You've built this humongous community. Why did you do it, and why should people still continue to follow what you're doing?
Well, as I said, I did it first of all to tackle the spread of misinformation, using authentic science and original content, but also at the same time to make science more engaging and more fun. Also, I am passionate about it. It's something that I love doing, and if you love something and you're passionate about it, you just enjoy doing it every day, and you will never get bored of it. And why they should continue is because of initiatives like this, and I continue to bring people up to speed with technology and the latest innovations like Metavisionaries, for example, and the Metaverse, and also my future projects, which include some interesting concepts about technology, and also the feature films that I'm working on, and the novels as well. So there's a lot of ways to make science more engaging and more fun, and yeah, I'm very excited about them.
Sabrina, I want you to end this because I know what you're gonna blast us away with something, right? So Hilda, what do you think? Last words.
Okay. No, I'm excited to see how this all connects and how we can really bring space and science and art to people's doorstep, to people's fingertips, and let them understand that you don't need to go off and study for years, but that it's really something that can be close to you, and where you can feel the excitement with us. And that's really, for me, what is important. I mean, we're bringing that cube, which by now has such a wealth of science, of art, of things that will be streamed, and such a community that is now attached to this small little cube that happens to go to space. It's fantastic. And to link all of that with the metaverse so that everybody can access it, it really gets me excited. Happy.
Amazing. Osman, if you wanted to quickly say your bit, and then I'm going to go to Jim. You muted again. You were unmuted and then you muted again. All right, I'm going to go to Jim. I'll come back to you. Jim, why? Last words on why this is so important.
Well, I don't believe the human race will be able to survive for well into the future without our ability to go into space, not just to look out, but to look down and to use that asset as only humans can. You know, we're the first species that can leave this planet. We are also the first species that recognizes that we can become extinct. And that knowledge is so critical for the survival of our species well into the future. And I think space is that critical element, and we need to learn as much as we can from that vantage point and use it to the benefit of humankind.
Jim, amazing as always. Sabrina.
As always. Yeah.
Yes, so I can speak, I think, all of my followers, Hashim's followers, and the people out there. It's really important and amazing that we have this opportunity, and everyone is dreaming about space and the universe, and everybody has the dream to go there maybe, so let's keep working on it. And please share the video, guys. Share the video everywhere.
Yeah. Okay, can everyone
It's
hear
fun
me?
to hear you. Yeah.
Yeah. So basically, as a kid, I've been a lot of interest in looking at the space and looking at the stars and looking at cosmos and doing some research on it. And there's always a question for every child or every adult as well: how big is the space, and how far can we go? How far can we reach to the stars? Will we go to the moon one day, to the Mars one day, or to the other planets, and find other Earth-like planets? It's always been a dream for every person, and a question which raises in every human being: how big is the space? So that's why I have a lot of interest in this astronomy and everything, and to explore and to go far and beyond. And it's been a dream for me just to get those answers, and is there life out there in space? So that's why I have a lot of interest in this Metavisionaries and space exploration and everything. And it's it's full of suspense. You don't know what's going to happen the next day. What else you're going to explore? And especially with James Webb Telescope, you can see a lot of amazing images out there, and so many galaxies and stars that it just opens up your mind, and it raises a lot more questions for the people out there.
Thank you, Usman. Now, all the audience, I'm going to tell you, there are aliens. Jim's hiding them. I know this for a fact. Now, normally Jim will only reveal this in certain environments. Usually when we take him to the desert, and he's kind of like, thinking about where his life is leading to and so on. There definitely are aliens. Jim is 100% hiding them. If you haven't followed him, follow Hashim. They're not giving you all the information, but if you follow them, they will tell you exactly where they're hiding. And I'll tell you
It's
that, Hilda, you know what I'm
classified
talking
when
about.
the time comes.
It is.
Yeah.
And Hilda knows this. Jim hides these aliens all the time. So Sabrina, the alien question is fair. Everybody, thank you so much. Hashim, you are fantastic. We really want to thank you for giving your time. Thank you for all the things you've been doing. And we're really looking forward to what you continue to do with your work, your movies. And I'm happy to be the guy that carries the briefcase. I'm happy. If you need that person,
Thank
I'm
you.
there.
I appreciate
All
that.
right. Just a small part is fine. Sabrina, you are lovely. Thank you so much for being here. And Hilda, again, lastminute.com. I just like, Hilda, jump on. Thank you. I want to say a big thank you to Usman and Camilo. Thank you so much. And Mariam and all the other team. Most importantly, I want to thank Jim Green live. He has
My
made
pleasure.
a mental difference to my life. I want to thank Tara, who's not here, who I wouldn't have met Jim without. So and everybody else. So have a great night. Thank you so much. Area 51 does exist. And we will speak again. For those of you who are interested in some of the work we're doing, please reach out. The space medicine course is going to be in November. We've got a lot of stuff lined up, and we will catch you all. I'd love for the guests to just stay back whilst I end the broadcast, and everybody else, have a good night. Take care. Bye.
Thank you. See you.